This is Note-Taking Guide 2.6 for Math 1. Today we're going to talk about how to solve some exponential equations here. So in order to solve an exponential equation, you actually have to have your numbers in the same base. So I guess the question is what's the base? So here we have 2 raised to the x. This 2 right here is the base. And this x right here is called the power or the exponent. So the base is the number that's raised to the power. So when we're looking at these two bases, I have a base of 2 here and I have a base of 2 here. Because my numbers are in the same base, I can solve the equation. So let me show you what I'm talking about here. So really what we're trying to do is find the value of x here. So it says 2 to the x equals 2 to the 5. Well, when we're in the same base, we can set the powers equal to each other. So x would have to be equal to 5. If 2 to the x equals 2 to the 5th power, then x would be equal to 5. And it's simple like that when they're in the same base, but here's this next one also in the same base. Base 3 is equal to something in base 3. So again, when we're in the same base, we can take those powers and set them equal to each other. So I can go 4x equals 12, which didn't really solve for me like the last one did, but I can solve this now. To get x by itself, I would just divide both sides by 4. And my power for x, or my value for x, is going to be 3. So x is 3. And it makes sense if you put it back up here. 4 times 3 is 12. So 3 to the 12th equals 3 to the 12th. So that does make sense. Okay, this next one, if you look at these are not in the same base. So what I'm going to do is I'm going to change them to the same base. I always want to change it to the number that has the smaller base if I can. So this is base 5. I want to change 25 to base 5. So if you'll think about it for just a minute, isn't 5 times 5 25? So 5 times 5, couldn't that be written as 5 squared? So 5 squared would be 25. So I can actually replace the 25 with 5 squared. So let me show you how I'm going to do that. I'm going to just take that and I'm going to say this is going to be 5 squared, and then that x is still up there as a power. And then this is 5 to the 6th power over here. Now that I have them in the same base, I can set the powers equal to each other. So 6 equals 2x. And then I can just solve both sides, or solve by isolating the x by dividing by 2, and I get x equals 3. So how do you know whether or not you did that right? Well, let's check it and see. So do on your calculator 5 to the 6th power and see if that equals 25 to the 3rd power, because really what we just said was that those were equal to each other. So if I raise 5 to the 6th power, I get 1, 5, 6, 2, 5. So 15,625. And I want to know if I get the same number when I raise 25 to the 3rd power. When I did that, I got 15625, so 15,625. So that actually checks out. That is correct. So you can always substitute those powers back in to make sure that they work. Okay, here's another one not in the same base. So this is base 7. So I want to try and get this into base 7, but I don't know what base. I know the base, I don't know the power. So what I'm going to do is I'm just going to guess on my calculator. I know it has to be 7 to some power. So grab your calculators and do 7 to the 1st, 7 to the 2nd, 7 to the 3rd, 7 to the 4th. Just keep raising your number 7 to powers until you get 343. So I figured out that 7 to the 3rd power is 343. So 7 to the x equals 7 to the 3rd. Now that they're in the same base, I can go x equals 3 and I can be done. So again, it's all about getting into the same base. All right, so this one's base 4, so I need this one to be in base 4. So find me the number that's going to be the power that I would raise 4 to in order to get 128. So 4 to the 3rd power is 64, so that didn't work. 4 to the 4th power is 256, so that didn't work either. So maybe I can't use a base of 4. Maybe I got to change to another number that I can use the base of in both of them. So maybe let's try 2, because I can go 2 to the 2nd power to get 4, and then that would still have the x minus 1 up there. Let's check 2 and see if I can get a power to work to give me 128. So try 2 to some powers and see if you can get that. I just tried 2 to the 6th and it was 64. So 2 to the 7th is 128. So I can actually change those both to base 2 to get this to work. So once they're both base 2, I can set the powers equal to each other. So I have 2 times x minus 1 equals 7. And then I can just solve. So 2 times x minus 2 equals 7. Continue to solve that by adding 2 to the other side. I get 2x equals 9. Divide both sides by 2. And I get x equals 4.5. So not a whole number this time. That's okay, you guys, if we get decimal point numbers for our solutions. It's totally okay. So again, I couldn't make it work in base 4, so I changed them both to base 2. All right, one last one right here. This is in base 2, so I'm going to see if I can get this one to be in base 2. So try 2 to the first power, that's 2. To the second power is 4. 2 to the third power is 8. So I can write this as 2 to the third power times x plus 3. And then this still stays as 2 to the 2x plus 1. Because I now have them in the same base, I can set the powers equal to each other. So 2x plus 1 equals 3 times x plus 3. My plus sign looks funky right there. So multiply this through. I get 3x plus 9 equals 2x plus 1. And then I'm just going to solve. I like to move my variables first. Again, I like to keep them positive. So they're gone over here. I get 1 equals 3x minus 2x is 1x. I don't really have to show the 1 there, but I'm writing it there this time. Get the x by itself by subtracting the 9 over to the other side. And I get x equals negative 8. Also okay to get negative powers or negative values for our x's when we're solving these. So the goal on today's is to get them in the same base before you try to solve them. Once they're in the same base, you can set the powers equal to each other and solve the problems from there. All right, you guys, good luck with your homework tonight.